Matthews, good to see you, or good to be seen by you. I don't know. We're looking at cumulative frequency, standard deviation, and variance, and it's out of HIJ in the text. Cumulative frequency we've talked about a little bit in past videos. It's the idea that maybe you have runners coming by, and as they come by, you measure the frequency that they come through, and you also keep a tally of how many people, like a running total of how many people have come through. So in this case, this example is like the Olympics, and you're standing there with a stopwatch, and instead of writing down everybody's times exactly, you just say, hey, between 2 hours 26 and 2 hours 28, 8 people come through. You go click, 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 make 8 clicks, and therefore your cumulative frequency at that point is 8. In the next 2 minutes, 3 more people come by, and so your cumulative frequency now is 11 because 3 people have come in. In the next 2 minutes, 9 people come in, so you add 9 to the 11, etc., etc., etc. Right? That's what's happening with this cumulative frequency table. That's nice to see how things are moving, and you can see like you add this to the previous, and you get that, and you add this to the previous, and you get that, etc., etc. That's kind of neat, but what's most useful about this is if you graph it. Oh, good, thanks. That's useful too. Is if you graph this as time and how many cumulative people have come in. And so that's what I want to show you next. Okay, so here's a graph, same data. And this is the time, t, and this is the number of people who have come in. So in the first like 26 to 28, here's 26, here's 28. I don't know exactly how the trickle in between here and here, but I know that by 26 I have 8 people who have come in, and at the end of 30 I have 11 people who have come in. Right, so at the end of 30, I have 11 people who have come in. Right? Ooh. Don't look over your eyes. And so I've done that one, I've done that one. At the end of 32 minutes, 2 hours 32 minutes, 20 people have come in. So 2 hours 32, now 20 people have come in. And I don't exactly know how this looks. Is it like that? So like a lot of people come in and then it tapers off, or not a lot of people and then a big pack comes in. But I'm trying to break this up into small enough pieces that I don't care. So we've got that. At the end of 34 minutes, 31 people have come in. So I'm doing that. Right. What I'd like you to try is sketch the rest of that and then line this up with a beautiful curve. Yeah, and see what you get. Okay. All right, so my dots were pretty close, but hopefully you have something like this. Right, here's all the dots. Here's at the end of 36, 12 more people come in from the 31, making 43. So at the end of 36, you get 43, right? And so you have all these data points. I don't exactly know how the runners come in between them, but they're in small enough increments that I don't care. And then we can kind of connect them with as smooth of a curve as we can. That's useful because we can interpolate data and look inside and make some predictions. Like, tell me, so what's the median finishing time? Like, when were half the people done? Well, half the people there's 70 people, there's 69 people, so 35, right? And so we can say, all right, well, so 35-ish people this is the median because the maximum number of people is 70. So this is if you lined all up the winner or the finishers all up, the first one has the number 1 on their chest and the last one has the number 69 on their chest. The one in the middle has the number 35, roughly. That person's the median. And you can find his or her time by starting at 35, walking over to the graph, and then going down to the time of the finishing. So that looks like, 34 and a little bit, so 32 hours, 34 and a little bit, right? So 2 hours, 34.5. right? So we're going to do that same trick with a couple of these other questions as well. So the second question was find the number of competitors who finished in less than 2 hours 35. Okay, well, here's 2 hours 34, 34. This is 36. This is 34, so this must be 35. There's no red lines in here. It's part of the example. You put your own red lines in. And the red lines are important on the IB exam. You need the red lines to show your answer or you don't get credit for it. Fun. So draw your lines in, right? So you go to 35, you go up to the curve, the cumulative frequency curve, run it over and see how many people. Now, provided that you have this line, the number that you estimate from here can be like off by 2 or 3 values, as long as you're kind of in the ballpark and show your work with the cumulative frequency curve. So draw your lines. So 37, right? 37, you sort of estimate, and I think they would give you credit for from 39 all the way to maybe 36, something like that. Just because maybe your curve, you draw your own curve, you draw your own dots, maybe that's off a little bit, maybe your hands are shaky because you drank too much coffee, trying to do the horizontal and vertical lines. Yeah, so 37. All right, and then what about this one? Percentage of competitors who took more than 239 to finish. Okay, well here's 238. Here's 240, so this must be 239. Let's go up and see just the raw number that finished more, who took longer than that. So these are the people who took longer than that, right? So, so 52 people had finished at time 239, right? So if you were there counting, the first people come in a little bit of time, click, 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 click. By the time you get to 2 hours and 39, you've clicked 52 people through. You've been like, yep, in. And therefore, there are this many people left over to come through. So how many competitors took more than that? Well, the 69 minus the 52. Where are they? So 17. And that's the raw number of people who took more time. We wanted a percentage. It asked for a percentage. What's the percentage of competitors? And so we have to say, oh, that 17, the rest, the leftovers, 17 out of the 69 people, so 26%. Cool. And then last, time taken by a competitor who finished in the top 20%. Now this is kind of run it backwards, right? Let's find like 20% of 69. So 69 people, the top 20%. So 10% is 6.9, 7. So 20% should be around 14. So I want the top 14 people. All right, so that's where, so you'd say, all right, well, so this is the top 14 people is the top 20%. It's the first 14 that come in. So here's around 14, right? Again, they'll give you some wiggle room provided you show what you're doing. This is my top 14, go over to the line, and then follow the line down. Oh, 2 hours 30, 2 hours 32, so this is like 2 hours 31. Again, they'll give you some wiggle room there, provided that you show your work. Yeah, let me check that. Yeah, so 2 hours 31. Neat. So cumulative frequency curves, useful and fun. All right, so there's some math equations coming on. We're going to look at this and this. Your calculator will do all of it, so put your safety specs on and just follow me for a little bit. We're going to look at variance and standard deviation. They're similar. This is more useful and more intuitive, but we have to go through variance first, and once in a while they'll ask us for variance just to be mean. So sometimes how spread out data is, data set is, isn't quite described by the range or the IQR. Like this is not very spread out, right? It's 4s and -4s. This is much more variable. If I have a class and this is their IQ, or I have a class and this is their IQ, this class is much more all over the place. This is much more predictable. So if you look at their raw data, the mean here is 0. Oh, the mean here is 0. If you add them all up and divide by 4. The median here is 0, and the median here is close to 0, right? If you like cut this off and find the average of these two, median 0. The range of this is 8, and the range of this is 13. Those aren't too far off. And the IQR of this is 8, and the IQR of this is 8. These data set, this data is very similar if you're just looking at like little kid statistics. But this really looks more spread out. So we need something more powerful to describe the spread of these, and that's where variance comes in and standard deviation. Okay, so let's try to figure out how that works. So we need to do something that shows how each data point is separated from the average. Here the average is 0, and so 4 is like 1, 2, 3, 4 above. This one is 4 above, and this one is 4 above, and this is 4 below and 4 below, right? And this one's 7 above and 1 above and 2 below and 6 below. I'm kind of visualizing like that, but they're all kind of averaging. I need a way to show like how much these are spread out in general. And if my face is in the right spot. Yo, mama's so mean, she got no standard deviation. If you have no standard deviation, you have no fluctuation from the mean, so you're very average. All right, so the average here is the mean. That's kind of like the baseline. And so if you thought about this data set, 4, 4, negative 4, negative 4, the mean here is 0, and you have 2 numbers above and 2 numbers below. The average distance there is about 0, and that's not very useful because like the amount up and the amount down cancels out here. And so we want something to accentuate this and talk about not necessarily about the negatives, kind of the negatives remove how far off they are. So I kind of want to say that like I don't really care that this is negative. I just want to say that this is 4 units away from the mean. And so removing those negatives sort of sounds like we could do something like take the absolute value. And if you took the absolute value of the change, right, the absolute value of all of these is 4. And if you divide by 4, the absolute value of all of this is 4. That's okay. Let's try that with the other data set. If you take the absolute value of this and this and this and mess with that, the absolute value of this one's also 4. So that's not very useful, right? Just removing the negative doesn't really make us see that this is more spread out, right? Okay, and I'm using these small data sets to make it look like, you know, make it easier to see what would happen with a really big data set that I couldn't look at all the data points and assume how spread something was. So but I got to get rid of these negatives, just keep like the size and how far they are from the mean. Taking the absolute value didn't work. Maybe squaring something, right? So if we squared the value, if you squared like -3, the square cancels out that negative. It's 2 negatives multiplied together. So let's try that with the 4s, right? So if we looked at this and this, and we said, oh, let's square that and square that. So those are 16s. And if we square this and square this, those are 16s, and we can divide them by the number of numbers. So this is the square of the difference from the mean on average, right, divided by the numbers. So that's 16. Let's try it with the other data set. If we do the same here, we go 7 squared, 1 squared, 6, -6 squared, and 2 squared. You get 90 over 4. And this has a larger average square distance, if that makes sense. So that's nice, but what does it say? That's nice, but this doesn't necessarily represent the 4-ness. Like it's not as accurate to how much on average each one is off, right? But what we found is called variance, and this is the equation for variance. Now, We've looked at, you don't need to memorize this. Your calculator will do this. I just want you to make sense of what's happening. We're looking at each value and the distance from the mean. So we're looking at 7. The mean here is 0. So 7 minus the average is 0, right? We're looking at the distance from the mean, finding that distance and squaring it. So that's 7 squared. And we're summing that. Remember sigma. We're adding those up. And then we're dividing by the number of numbers, 4. So that's what this equation does. Your calculator does it. You just need to be able to decode a little bit of it. These are too big. Like, there's nothing 16 about this, and there's nothing 22 about this. So let's try something. Let's try to take that and modify it a little bit to get it a little closer to how far off this is. And if you took the square root of this, 16, you get back to 4. And these are kind of like 4 off, right? And if you took the square root of this is like little more than 4, a little less than 5. And I would say on average, these are about 5 maybe away from the mean, 4 or 5 away from the mean. And these are definitely 4 away from the mean. And so if you take the square root of that variance, you get 4 and you get 4.7. And that's a little closer to actually me visualizing that these are on average, each one of these is on average about 4 away from the mean. And visualizing that these on average are like a little closer to 5 away from the mean. I know that like, and this says that they're more spread out because they're farther away from the mean on average, right? What we found is standard deviation, and it's the exact same thing as this one, except we've taken the square root of the top. Ooh. Now, amazing IB trick that they love is they give you variance. They'll say the variance is 25 and ask you for the standard deviation. And the stupid trick you got to know is square root, and you get standard deviation. Or they'll give you the standard deviation. They're like, oh, standard deviation is 8. And they'll ask you for the variance. And you have to know the stupid trick is the variance is the standard deviation squared, right? And so you go, oh, all right, 8 squared, 64. That's the fussy trick. You don't need to know this, the equation inside, but you do need to know A, how to get this with your calculator, and I'll show you that in a second, and B, the standard deviation, the variance, the square root of the variance is the standard deviation, and therefore the standard deviation squared is the variance. I don't think that's in your formula booklet. That's something that they want you to memorize, I think, and I don't know that it's particularly useful, annoying little trick, but remember that part. Okay, let's find this with our calculator. Here's a list. Let's do a different one in your calculator. Let me just show you this. If you put L1 in your calculator, 4, 4, negative 4, negative 4, and you put a second, there's our other data set. I did this twice. I did this once for list 1. You go into one variable statistics. I'll show you this in a second with a different data set. And it gives us the mean is 0 for this one. Oops. List 1 is, let's do it in purple. This is this one. 0 mean as we thought. This is the standard deviation. Yeah? It's this little scripty sigma. Looks like a 6. This one is also standard deviation, the big S. That's population versus sample standard deviation. We're always going to use this one. You never use that one in this course. This data set is L2. Look, mean is also 0, but the standard deviation is 6.7 like we thought. Cool. Let's try to do that by hand. This is, sample standard deviation is this piece, and they vary slightly in how they are calculated. One just has an n-1, and it represents like a smaller piece, and as if you didn't sample everybody. The population standard deviation assumes that you've sampled everybody and doesn't have this little modification. We won't use this. We will always use this. but I just wanted you to see what's the difference. There's a little modification for if you've polled everybody or not. Anyway, we're always going to use this one. It's population. Okay, so let's try this on our dang selves. Here's a list of data. We're going to put it in our calculators, and we're going to try to find standard deviation, and then therefore the variance. Statisticians are mean and slightly deviant. Okay, so I took the liberty of punching these in for you, so you don't have to watch me wade through them. 67, 72. I went to stat edit. If you have stuff in your lists already, you can go up to L1 or L2 and hit clear, and then go down and it'll clear it out. Then go into stats. We want it to calc something for us, a one variable statistic. All my stats are in list 1. I have no frequency list. I'll show you on a different video what that means. So if you have if you have a lot of 67s and a lot of 72s, you can just put in 67, 72, 75, and then in list 2 say how many you have. I'll show you on another video so this doesn't go too long. Calculate, and that's what I got. Let's see if that links up with this piece. So I got 84, and the standard deviation is 8.8, and that looks about right. Okay. Now that we have standard deviation, notice like none of those is variance. So if they said, what's the variance? You'd say, okay, well, the variance is really standard deviation squared. So that's 8.8 squared. So 64, 72, making stuff up. Well, I guess we can just do it our dang selves. I do have a calculator right here. So you could say 8.8 squared. 77. Go ahead. 77. Cool. So what this means is on average, all of these points are on average 8.8 units away from this mean value. So if the mean value is 84, 67 is going to be down here, 72 is going to be down there, 75 is going to be a little closer, etc. 85's really close, 88's a little higher, right? And on average, they're about 9 units away. They're all about 9 units away from the mean. And that helps you compare it to other data sets and say which one's more spread out, which one's less spread out. Cool? All right, there's some homework, and get to it. We'll see you later.